Part 2 of 2.5. In these examples, A through D, it gives us a g of x function. It wants us to identify what f of x is. Okay, I'm going to do that right underneath here. What f of x is, it wants us to graph, well, and f of x is the original, okay, the basic function. What is the basic function? Is it a square root? Is it a square, absolute value, so forth, okay? Once we find that, we need to graph it. We need to graph the transformation, and that's all we're really expected to do. So we have x squared minus 6. Well, this is the basic function x squared. I mean, it's in the words when you read it, x squared minus 6. And the graph of x squared, our vertex is at the origin, and it looks something like this. I don't worry too much about the exactness of the graphing, because generally when I do it in the homework, it lets me choose an example, or it lets me pick from like a multiple choice type scenario. Okay, so now that I know that I have an original basic function of x squared, I need to look at the transformation g of x and identify an inside and an outside. So the inside is what is being squared. Um, X is being squared. So x is on the inside, just x, and on the outside we have minus 6. Well, since there's nothing but x on the inside, that means that I do not move horizontally, okay, because x is by itself on the inside. On the outside, I have minus 6, so I'm going to move that vertex down 6 units. And that's all we have to do. We did not move horizontally because nothing happened on the inside. Half the battle in math a lot of the times is knowing what it's saying. In front of us in example B, it's not saying bar x minus 4 bar. I mean, that it looks confusing, but if you've never seen that before, it's an absolute value. So it's saying the absolute value of x minus 4. Okay, so the operation f of x, the basic function, the basic function is the absolute value of x. I'm going to go ahead and graph that. We can sort of almost memorize the graphs from the notes that we were given, the blank notes that I have already went over, but it's just a v, okay? So now I need to determine inside, outside. Inside will always be what's being operated. What is inside of the operation? The operation being the absolute value. Well, I have a minus 4 on the inside. Okay. So when I have something on the inside, that means move horizontal. Okay. And we sort of do the opposite. So since it says negative 4, that means move right 4 units. There is nothing on the outside. So that tells me that I do not move it all vertically. So this is the transformation, the graph of g of x. In example C, we have the square root of x plus 2. So I need to find the original function, and it's the square root of x, the basic function, okay? Now, the notes that I went over earlier, the first page of this blank sheet of notes, tells me that the square root function looks something like this, okay? So once that is graphed, I'm going to think about the transformation, okay? So we have the square root of x right here, like on the original, the square root of x is on the inside. Well, here in the transformation, x plus 2 is on the inside. So it means move horizontally. And since it says plus 2, I sort of think the opposite. I'm going to move left 2 units. There's nothing happening on the outside. So I just draw another simple sketch of that graph, and this is the transformation. Let's read D together. H of x equals the square root of x plus 2 minus 3. So I said square root of x, didn't I? So it's the same basic function as last time, or I can think of it as a mother function or an original. And so I'm going to graph the square root of x really quickly, and that's sort of uglier than what I intended on it being. There we go. Okay, now the square root of x plus 2 is on the inside. Plus 2 is on the inside. That means I move left 2 units. And then minus 3 is on the outside. So that means I move down 3 units. So remember, if it's on the inside, it's horizontal and you do the opposite of what the number is saying. And if it's on the outside, it's vertical and you do exactly what the number says. So let's draw our transformation in red. We're going to go left 2 units and down 3 units and draw our vertex. And then we just draw that little square root looking graph.